Problem 2 is almost identical to problem 1, except here we want to test whether males earn more than females. Now, because the problems are algorithmically generated, the means, the variances of the two samples, sample sizes have changed. With the new numbers from problem 2, the sample mean of males was 49,840, and this time it's greater than the female average. The sample variances of male and female are different, and instead of 38, we have sample sizes of size 37. The point estimate of the difference between the male and female averages from the samples is now positive and equal to 2,777, which means males are making more than females on average. But what we're interested in this problem is whether that difference is significant. The standard error is equal to $1,308, with the significance level at 1%, and this being an upper tail test. We divide the alpha by 1. This right here is the calculation of the degrees of freedom, which now is 71.410, because we always round down that calculation. The degrees of freedom are 71. So we have to find the critical value of this test in column 0.01 and row 71. In column 0.01 and row 71 of the t-table, the upper critical value is 2.380. The test statistic is the point estimate of the difference divided by the standard error. Which is 2.1231 to 4 decimal places. We're going to copy these values into Cengage now. So the test statistic to 4 decimal places, 2.1231. The point estimate of the difference in population means to 0 decimal places is 2,777. The standard error of the difference to 2 decimal places is 1,308. Because the population standard deviations are unknown, we have the type of degrees of freedom in here, which were 71. So we're going to go to row 71 and column 0.01 of the t-table to find the critical value. And the critical value was 2.38. In part F, we have to conclude the test. Now remember, the problem was asking whether or not males earned more than females. If males earn more than females, then the difference between the male average and the female average is greater than 0. So the alternative hypothesis is male average minus female average is greater than 0. So the null hypothesis is that difference is less than or equal to 0. When we're trying to figure out if we reject or not reject the null hypothesis, we have to compare the test statistic to the critical value. Now, since the alternative hypothesis says the difference is greater than 0, in order to say that that is true, the test statistic has to be greater than the critical value. Since the test statistic is less than the critical value, we have evidence in support of the null. So the null hypothesis cannot be rejected. Thus, we cannot say males earn more than females. And we check our work, and we get all the questions correct.